we are going to understand one of the most basic and important sorting algorithms, bubble sort. If you are a beginner in DSA or preparing for coding interviews, this algorithm is a great starting point. We will understand how bubble sort works, its logic, time complexity, and then implement it step by step in C++ using VS Code. So let's get started. So the first question is, what is bubble sort? Bubble sort is a comparison-based in-place sorting algorithm. The idea is very simple. We repeatedly compare adjacent elements and swap them if they are in the wrong order. In every pass, the largest unsorted element bubbles up to its correct position at the end of the array. That's why it is called bubble sort. How bubble sort works? Let's understand. Okay, so in the bubble sort, after each pass, the largest element bubbles out at the end. So by understanding with this example, this is the array 5, 4, 3, 2, 1. So in the first pass, we compare 5 with the 4. Here 5 is greater than 4, so we swap, and the resultant array will be 4, 5, 3, 2, 1. And then again we compare 5 with the 3. So here 5 is also greater than 3. So we will swap this position, and the resultant array will be 4, 3, 5, 2, 1. Again we will compare 5 with the 2. Here 5 is also greater than 2. So we will swap. So the resultant array will be 4, 3, 2, 5 and 1. And at the end we also compare 5 with the last element. So 5 is also greater than 1. So the resultant array will be 4, 3, 2, 1 and 5. So after the first pass, there will be 4 comparisons. So if you check, we compare 5 with the 4, and then 5 with the 3, then 5 with the 2, and at the end 5 with the 1. So there are, in the first pass there are 4 comparison, and here the size of the array is 5. So in the first pass we had did 4 comparisons. In the second pass, as the arrays as the last element already sorted, we check 4 with the 3. So here 4 is greater than 3, so we will swap. So the resultant will be 3, 4, 2, 1, 5. Then again we compare 4 with the 2. 4 is also greater than 2, so we will swap, and the resultant array will be 3, 2, 4, 1, 5. We will again compare 4 with the 1. So here again 4 is greater than 1, so we will swap. And at the end we will not compare 4 with the 5, because 5 is already the largest element and it is at its correct position. So now the array will become 3, 2, 1, 4, 5. In the second pass we did only 3 comparisons, and in the second pass the second largest element is at its correct position. So now for the third pass we will again check, this will be the resultant array. So we will again check the first element to its next element. So we will compare 3 with the 2, and 3 is greater than 2, so we will swap it. The resultant will be 2, 3, 1, 4, 5. We will again check 3 with the 1. 3 is greater than 2, so we will swap it, and we will do 2, 1, 3, 4, 5. And we know that 4 and 5 is at its correct position. So at second comparisons we got 3 at also at its correct position. The third element is also at its correct position. So in the third pass, with the help of 2 comparisons, the last 3 elements are at its correct position. And for the fourth pass, at the last pass, we will compare 2 with that 1. 2 is greater than 1, so we will swap it. And with the 1 comparison, all the elements are at its correct position. So with the fourth pass and 1 comparison, the array is sorted. So in short, this is the bubble sort. After each pass, the respective element reaches to its correct position. So if we consider the size of the array is n, which is equals to 5, then the total number of passes will be n minus 1. Like for the 5, it is 5 minus 1, which will be 4 passes. So here the total number of passes for the bubble sort is 4. 1, 2, 3, 4. And at each pass, the final element reaches at its correct position. So we did not compare the last element with the correct element. So if with every passes the number of comparison decreases. So all this we will see in the code. Okay, so let's continue with our example of the array 5 4 3 2 1. With the size, we get the size of the array, and as we discuss, we need n minus 1 passes. So for that we will use for loop. So for the simplicity purpose, let's take n here to continue with our example, and there will be n minus 1 passes. Okay, and each pass there will be the comparisons of the element. And so for that we need to again write another for loop, and here we will use another variable j, and the most important part, the number of comparisons. The number of comparisons will be decreases as the passes increases. So here we need to use n minus 1, and to decrease the last element we will use I here. Okay, as for the first pass I is 0. For the first pass I is 0, n is the size, so 5 minus 1 4. So for the first pass there will be 4 comparisons, and for the second pass I will be 1. So 4 minus 1 3 minus 1 2. So there will be 2 comparisons for the, so sorry, there will be 3 comparisons for the third pass. Again, for the I is equals to 1, 4 minus 2 which is equals to 2. So for second pass there will be 2 comparisons. Sorry, so for I is equals to 1, size will be 5 minus 1 4 minus 1 3. So for the first pass there will be 3 comparisons. So yeah, with this we will write our logic, which is if data of current element is greater than, which is 5 here, if we continue with this example, is greater than data of j plus 1 which is equals to 4. If 5 is greater than 4, then what we do, we write the logic to swap it. Okay, okay, so this is the simple logic of swapping the element. I hope it is clear. So okay, so we had to write a logic to swap an element. If 5 is greater than 4, so it will swap this element, and yeah, it will continue with our logic. So let's check it. I is equals to 0, I less than, and it's okay. If you check, the array is sorted. Let's dry run this code. Okay, so let's dry run this code. For I is equals to 0, here n minus 1 if we take an example, the value of n is 5, which is equal to size, and the n minus 1 is equal to 4. So as per our logic, there will be 4 passes. The total number of passes will be 4 passes here. The outer loop will be for the number of passes, and the inner loop will be the number of comparisons. So for the first pass, so if we continue for the first pass, the number of comparisons the inner loop will do is 5 minus 1 minus I. The value of I is 0, so the resultant will be 4. And for I is equals to 1 is equals to 5 minus 1 minus 1, which is equals to 3. For so like for second pass there will be 3 comparisons. If we check here, for I is equals to 2, here 5 minus 1 minus 2, which is equals to 5 minus 2, 3 minus 1, 2. 2 comparisons. So for third pass it will be 2 comparisons, and for I is equals to 3, which is equals to 5 minus 1 minus 3, which is equals to minus 2 minus 1, 1 comparisons. So for the fourth pass there will be only 1 comparison. So our logic is correct. Okay, now let's take example of this question, which is 1 2 3 4 5. Here the array is already sorted, so with our logic it will do all the n number of passes, which is unnecessary. But even if the array is sorted, it will end up doing n minus 1 comparisons. So to optimize this, what we can do is we can use a boolean fact to check if any comparisons happens. If no comparison happens, which means that the array is already sorted and there is no need for the further comparisons. So for that we can use a boolean to check is swap happen. We can deem as false if any comparisons happen, like if data of I is greater than data of j plus 1, which means array is not sorted. Then what we can do is we can check it to true, and at the end of the first comparison we will check if not swap happen, if no swap happens, simply break, and that's it. With this we can optimize the performance, we can reduce the number of comparisons of the array. You can use this in an interview to optimize the algorithm, bubble sort algorithm. Okay, and one more thing, bubble sort is stable sorting algorithm, which means the number of relative positions stays same. Here if I take an example of another, which is 9 8 7 7, and if you check for the, we will compare 9 with the 8, 9 is greater than 8, so we will swap it, so it will become 8 9 7 7. If we compare 9 with the 7, 9 is also greater than 7, so we will swap it. so it will become 8 7 9 7. Again we will compare 9 with the 7, so 9 is greater than 7, so it will again swap the element, so it will now become 8 7 7 9. And then for the next we will compare 8 with the 7, 8 is greater than 7, so it will swap with the 8 7 9. Again it will check 8 with the 7, it is greater than 7, so it will swap, so it will 7 7 8 9. If we check, the array is sorted, although there are two 7, the relative order of the 7 stays as it is, it does not change, so which means that the order in which they had in the previous maintains the order till now. So bubble sort is a stable algorithm. Bubble sort is stable algorithm. Yeah, this is one important thing. Now let's talk about the performance. Time complexity and space complexity. The worst case complexity, the worst case time complexity, time time complexity, the worst case and average case also. Big of n square, big of n square, because if the array is completely in descending order, so there will be n and n, which is n square, there will be each and every swap over there, so the worst case and average case time complexity is big of n square. The best case time complexity can be big of n if we optimize the algorithm with the boolean flag. So the best case time complexity with the help of the boolean we can round up to big of n, because there will be one iteration to check whether the array is sorted or not. The most important thing here is the space complexity. Here we are not using any extra space, the sorting is happening in place, so the space complexity is big of 1. Now the most important thing is bubble sort is simple but not suitable for large datasets or production level applications. When to use bubble sort? Bubble sort is mainly used for learning purposes and for understanding how sorting works internally. In the real world application, faster algorithms like quicker sort, merge sort or heap sorts are preferred. So that is bubble sort. Simple, easy to understand and great for beginners.